I, I think I'm recording. Let's take a look at problem 34 of our semester review problems. It's wanting us to use the remainder theorem to show that 1 and 2 are zeros of the function. So really, the factor theorem and the remainder theorem. Um, so if 1 really is a zero of this function, if we do synthetic division with 1, then we should get a 0 as a remainder. When we do synthetic division, make sure that your polynomial's in standard form. Make sure that there's no missing powers on x. So here it is in standard form. There's no missing exponents, no missing powers on x. And so if it's true that this graph really does cross the x-axis at x equals 1, I should get a 0 down here. So let's see if that's true. The 2 comes straight down. I multiply by 1. I add. I multiply by 1. I add. I multiply by 1. I add. I multiply. So I did get a 0. So I agree that 1 is a 0 of this function. So now I'm just going to go ahead and continue using this result to continue doing synthetic division. If it's true that 0 if it's true that 2 is a 0, that 2 is an x-intercept, again, I'll get a 0 here. Let's see if that's true. The 2 comes down, I multiply, I add, I multiply, I add, I multiply, and I get another 0. So what this helps me do now is to factor. See, I don't have an x method or any real way to factor this 4th degree polynomial. But now that they've given me a little bit of a clue and this knowledge about the remainder theorem and the factor theorem to help me, I now know that this polynomial function f of x factors to x minus 1, to x minus 2, and to this guy right here is a quadratic 2x squared plus x minus 3. Now it wants me to find that the zeros, the additional zeros. So we already know that 1 and 2 are zeros, but we're going to get possibly 2 more zeros over here. And we also want to talk about their multiplicity. So if I set this equal to 0, I've got x minus 1 times x minus 2. If I factor this, I've got 2x times x is 2x squared. I need two numbers that multiply together to give me negative 3, but add to give me a positive 1. So if I use 3 and negative 1, and if I multiply that, negative 2x and 3x, so there, I've got that. Now, I notice that I have x minus 1 here and here, so that x minus 1 has a multiplicity of 2, and this x minus 2 here, 1, and this 2x plus 3, 1. So I always like to just present my zeros and the multiplicity, and it didn't ask, but how it intersects the x-axis, all just in the form of a table. So my zeros, or my x-intercepts, are 1, 2, and they gave me that. I didn't have to. And the one that I found was the negative 3 halves. Now the multiplicity, I didn't know at the start of the problem that the multiplicity at x equals 1 would be 2. Here at x equals 2 it's 1, and here it's also 1. So if I add these up, I should get the degree of the polynomial. The degree is 4. If I add that column up, I get 4. It didn't ask me, but I can tell you how it intersects the x-axis, because if it has an even multiplicity, it touches it, and I like to call it a touch and turn. And if it has an odd multiplicity, it just crosses through it. So that tells us a lot of information about the shape and what the graph looks like without ever having to make a table of values and sit here and be tedious and plot point after point after point. So this is what it asks for. Let's make sure I gave you some additional. This is what it asks for. All right, so hey, I hope that helps, and I'll talk to you later.